Hello all, this video has been created as a part of a computation experiment for the Electromagnetics Lab at IIT Delhi. In this video, we have compiled our results involving the simulation of wave scattering phenomena. Wave scattering or diffraction is an interesting wave behavior which plays a big role in our perception of waves. It is the slight bending of a wave when it passes around the edge of an object or through an opening in between barriers. Diffraction creates several interesting natural phenomena. It can be observed when water waves travel through a small gap, resulting in beautiful ripples over the water surface. It can also be observed in light waves when they are scattered through thin clouds and other particles in the atmosphere. The result is a pattern of rings which seem to emanate from the sun. The scattering of sunlight at short wavelength, that is, the blue end of the spectrum, is the reason that the sky appears blue. The degree of bending therefore depends on the relative size of the obstacle to the wavelength. In our experiment, we have performed simulations for a different value of this ratio using the Meep software, which utilizes numerical technique called finite difference time domain, which discretizes both time and space partial derivatives using central difference approximations. Our domain size was 32 by 32 Meep units. It remained the same for all regimes, only the obstacle size was varied. We placed the source at -4,0 and the object at 4,0. Since we are using a finite domain, we have used the perfectly matched layers of thickness 1 unit as an absorbing boundary to reduce the disturbance from the unwanted but inevitable reflections from the borders. We have studied 3 different regimes of wave bending. In the first one, the obstacle size is approximately half of the wavelength. It can be observed that here, the wave propagation is almost unaffected by the obstacle and the wave travels undisturbed primarily because the size of the object is too small to produce significant disturbance. In the second case, we have kept the object size equal to that of the wavelength. So now we see increased disturbance in the pattern. Some waves are reflected from the object and the reflected waves interfere with the incoming waves to create an interference pattern on the left side and a shadow region on the right side of the object. In the third case, the object is much larger, approximately 3 times of the wavelength. So now there is hardly any diffraction and interference between incident and reflected waves has increased dramatically and there is linear propagation of wave. Here a large shadow region can be seen on the right side of the object. Here is a table enlisting the parameters used during the experiment. This is a code for the first regime where the object length was 3 units. Here the object length was 6.7 units, and finally the code for third regime where the object length was 18 units. With this, we conclude our video. Hope you enjoyed it and thanks for watching.